Hello, I'm Dr. Musil, and in this video we're going to talk about assessing arguments using truth tables. And I'm going to try to kind of kill two birds with one stone by also discussing those common argument patterns that the authors alluded to in the textbook as well. So in other words, modus ponens, affirming the consequent. So not only the common valid forms, but also the corresponding fallacies as well. So modus ponens, affirming the consequent, modus tollens, etc. And the plan of attack is I'm going to go through each of these in turn, sort of show you what the basic form, and then give you examples, and then show you what the truth table looks like and kind of how you work with the truth table to figure out the validity of an argument, to decide whether or not it is in fact valid or invalid. Okay, so without further ado, let's go ahead and dive right in. Like I mentioned, I want to work with the very common argument patterns that they referenced in the textbook. So we'll start with what's known as modus ponens. This is such a common argumentative pattern that it actually has a name, right? This is very, very common. Anything that fits this form, as the authors pointed out, is going to be deemed valid because this form, no matter what's substituted for these variables, is always a valid form of argumentation. Okay, so you could substitute anything you want in for these variables, and whatever results, as long as you're consistent in plugging things in for these variables, what results is always going to be a valid argument. So this is again known as modus ponens, and I put affirming the consequent to the side here because that's the corresponding fallacy that is often thought to be a valid argument when it's not, but it's thought to be valid because it so closely mirrors modus ponens, but we'll see there's a very slight difference, and that's all that it takes to make this form of argumentation invalid. No matter what you plug in over here, it's always going to be an invalid form of argumentation. So let's start with the modus ponens. Okay, the form of this argument is if P then Q. Okay, premise 2 then is P, right? We're told, okay, P is the case. And then the conclusion simply is the consequent of the original conditional in the premise, right? Q. So again, we're told if P then Q for premise 1, then we're told for premise 2, P, which was the antecedent of the conditional. So then the conclusion is that the consequence is going to follow, that Q will be the case. So let me give you an example. I always think it's beneficial to map up actual examples onto these underlying forms. So here's what an actual modus ponens argument would sound like, and it makes intuitive sense if you just listen to what's being said. Premise 1, if it's a cat, it's an animal. Premise 2, it is a cat. So the conclusion then is, it's an animal. Now, when we're asking ourselves intuitively what needs to be the case, again, to render this a valid argument, right? We need to ask ourselves, if I assume all these premises are true, does the conclusion have to be the case? So if I assume that if it's a cat, it's an animal is true, and that it's a cat, right, does it have to be the case then that it's an animal? And it does, right? Because you're told that if it's a cat, right, it'll also be an animal, okay, given the first premise. So if that first premise is true and it's a cat, well then it's got to be the case that it's an animal, given the way a conditional works. Okay, so you can again substitute anything you want into or onto this form, right? And whatever you produce is going to be valid, assuming that again you are consistent in plugging things in for the P and Q, right? So you could say something like, if he's a Patriots fan, then he loves Tom Brady. Premise 2, he's a Patriots fan. Conclusion, he loves Tom Brady. That's going to be valid, right? Assuming those premises are true, that conclusion will have to be the case. So real quick, let's go ahead and see how that works, right? So some of your homework problems require you to use the truth table method to figure out whether or not an argument is valid or not, right? So let's go ahead and see how that works then, right? So actually I should use C and A because that corresponds to cat and animal, and that was our example. So let's go ahead and do C and A for cat and animal. Okay. So, right, we have our reference columns, right, which always reference the original claim variables without any logical operations or symbols involved. So I've changed this to, if it's a C, then it's A. It is a C, therefore it's A, right? And that is actually the logical notation for this sort of average, everyday, ordinary expression of the argument, right? If we were to translate that into the logical notation we've been talking about in the previous videos, this is what it's going to look like, right? So here we have our argument, okay, and we want to put that then into a truth table to then be able to look at all the possible combinations of truth values to decide or determine whether or not there are going to be any instances, possible combinations, wherein both the premises are true and the conclusion is false, right? Because that's what we need to find to be able to say that that's an invalid argument. If we can't find a single row in the truth table corresponding to the argument where both the premises are true and the conclusion is false, if we can't find such a row, then the argument's valid. Okay, and my guess is, since we already know, right, that this is always going to be a valid form of argumentation, that we're not going to be able to find such a row. But let's find out, right? So the reference columns, C and A, again, as we've talked about in previous videos, the far left one's always going to consist of the first two rows being true, and then false, false. And then the next one over, true, false, true, false. All that's left, right, because our second premise and our conclusion are basically the reference columns, right? They're just the claim variables themselves. And notice how I've clearly indicated that here, right? Premise 2 is this column, okay, and the conclusion is this column. All that's left then is to go ahead and create a new column for that symbolization that's involved in the conditional, right? If C, then A, okay, and that's going to be our first premise, okay? So again, when is a conditional false? If and only if the antecedent, the first thing, is true, and the consequent, the second thing, is false. Okay, so here we have C is true, but A in this row is also true. So the conditional as a whole is true. What about this row? The antecedent's true, but ding, 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 the consequent is false. So here we have an instance where the conditional as a whole is false because the antecedent's true and the consequent is false. Okay, and then the third and fourth rows, anytime that antecedent's false, okay, we can't say that that conditional is false, right? Because to say that it's false, the antecedent has to be true, and then the consequent has to be false, right? So anytime the antecedent is false, we already know right off the bat, right, that the conditional is going to be true. Okay, so true, true there. So we only had one instance or one row where the conditional turned out to be false, and that was when C was true and A was false. Okay, so now let's step back. Once you've got everything from the argument put onto your truth table, right, either via the reference columns or additional columns where you've included the symbolization involved, right, with the logical operators, then you're in a position to step back, find those premises, the columns corresponding to the premises, right, and see where you have instances or rows where, like here's an example, where both the premises are true. That's the first thing you got to find, right, is a row where both the premises are true, okay, because that's going to be needed to prove that the argument's invalid. All the premises have to be true. In this case, there's two premises. You've got to find rows where both those premises are true. Okay, here they are, they're both true, but the conclusion is also true. So this row does not render the argument invalid. Yeah, both the premises are true, but so is the conclusion. We need to find a row where both the premises are true, and yet the conclusion is false. So this one checked out. It's not going to show that the argument's invalid. This row, both the premises aren't true, right? So it can't show that the argument's invalid. Same thing here because we have premise 2 is false in this one, and same thing in the last one. The fourth premise is false. So, or sorry, in the fourth row, the second premise is again false. So there was only one possible row that we could have shown that the argument was invalid in the sense that both the premises were true, but in that row, the conclusion turned out to be true, right? So we still didn't show that the argument was invalid. And so lo and behold, the argument is actually valid, okay, because there's no row where the premises are both true and the conclusion is false. Okay. Let's turn our attention now to a very closely related form of argumentation, but we have a very subtle difference here, and that's all that's needed to then, as I mentioned earlier, render the entire argument invalid. And let's switch it over to C and A's again. Okay. So look, Very, very similar form, right? The first premise, in fact, is the exact same. If C, then A. Now look, though, at the second premise. This time, though, we're affirming the consequent, right? We're saying the consequent of that original conditional is also true, right? So assume this is true and assume this is true. Then they want you to infer that this is going to be the case. That's always going to be an invalid form of argumentation. It's always going to be possible to assume these are true, and yet this can still be false. Okay, let me give you an example. One that I think, again, intuitively sort of sounds invalid, right? If you really think about what's being said. Premise 1, if it's a cat, it's an animal. Premise 2, it's an animal. The conclusion then is it's a cat, right? No, that doesn't have to follow, right? We're being told something about, look, what will happen if it's a cat, not about something that will follow if it's an animal, right? So just knowing this doesn't mean it's going to be a cat, okay? So let's see via the truth table why this is invalid or how this is also invalid. So we'll start with C and A again as our basic reference columns. True, true, false, false. And then true, false, true, false. Okay. And so we already have our second premise. Premise 2 is here on the A, right? And then the conclusion is also up there, this column. Okay, so we clearly indicate that. And then all that's left is to, again, put that conditional in here. If C, then A. So now we need to go ahead and find the truth value in every row for this conditional. Okay, antecedent's true here. Consequent's also true, so it'll be true. Here we have an example where the, yeah, that's correct. So here we have an example where the antecedent is true, but the consequent is false. So that would render the conditional false. Okay, and the third and fourth rows, just like the last table we were dealing with, the antecedent is false in both circumstances or both rows, so the conditional itself as a whole will be rendered true. Okay, so now we have our first premise drawn up here. So we can step back and we can analyze the validity of this form of argumentation or this argument, right? So again, this is the logical notation representing, right? It's logically, truth functionally equivalent to what was expressed here. Okay, this is always going to be, true when this is true, and this is always going to be false when this is false. Okay, that's what it means again to be truth functionally equivalent. Okay, so we've represented this argument with this underlying form, right? The logical notation here. So let's step back and see if we find any rows, right? Any scenarios where both the premises are true and the conclusion is false. Well, here, the very first row, we have an instance where both premises are true, okay, but the conclusion also turns out to be true. So this will not render the argument invalid, okay? So it checks, it's fine there. Here, both the premises are false, so we don't have an instance where both premises are true. What about this third row? Well, they're both true, and ding, 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 the conclusion turns out to be false. So here we have a scenario where this argument will turn out to be invalid, right? Where we can assume the premises are true. Look what happens. We assume the premises are true, and it can still be the case that the conclusion is false. Okay, and I want you in your homework, on the quiz, etc., to very clearly indicate on your truth table, what row or rows, right, indicate that the argument's invalid. And so those will be the rows where the premises are all true and the conclusion's false. Okay, now the fourth row, not all the premises are true, so that fourth row is not going to indicate an invalid argument, but the third row does, right? So when C is false and A is true, right, when we plug those truth values in for C and A, the whole argument, right, itself will turn out to be invalid, right? We'll get true premises when we do that, and we'll get a false conclusion, okay? So there's the truth table indicating why, right, affirming the consequent is an invalid form of argumentation. Okay, so that's modus ponens and affirming the consequent. Let's move on to what is arguably the second most common argumentative form that you'll encounter, and that's what's known as modus tollens. And we'll we'll juxtapose that on the board with what's called denying the antecedent. Okay, so like I did before, I'm going to go ahead and put the basic forms up here and then an example. So it again starts with a conditional, if P then Q, and then we're told it's not the case that Q, right? And so then the inference is, right, that we can conclude it's not the case that P. Okay, let me put up a quick example here. It's actually very similar to the previous example. Oops, I was going to use C and A again. Keep forgetting that. So, because this will better correspond to the example I use. So if it's a cat, it's an animal, it's not an animal, and so the conclusion will be it's not a cat. Okay, and again, if you just think about it on the face of things, that sounds like it would be the case, right? That assuming those premises are true, that conclusion would be the case, right? If it's a cat, it's an animal. So we're told, look, if it's a cat, it has to be an animal. Then we're told it's not an animal, right? So it couldn't be a cat. That's the conclusion, right? It couldn't be a cat because if it was a cat, it would have had to have been an animal. And in premise 2, we're told it wasn't an animal, right? So it should sort of intuitively make sense, and that makes sense because it's a valid underlying form of argumentation, right? Known as commonly as modus tollens. Now on the flip side, we have a very similar looking but slightly different form of argumentation that, given the slight difference, turns out to be invalid at all times. And my example is very similar. If it's a cat, it's an animal. Premise 2, it's not a cat. So they want you to conclude then it's not an animal. So to sort of intuitively see why this seems invalid, right? Imagine that I have something behind, right, the curtain here, or the paper in this case. Right? It's a sentient creature of some sort, or it's an object of some sort, it's something of some sort, right? And I say, look, if it's a cat, it's an animal, and then I say, but it's not a cat, right? Does it then have to be the case that it's not an animal? No, it could still be an animal, right? We were just told that if it was a cat, it would have to be an animal, right? So just negating the fact that it's a cat doesn't mean that it can't still be an animal, right? So no, what's behind the curtain could still be an animal, even though it's not a cat, okay? So again, it doesn't matter what argument you choose, right? If its underlying form is this, which is the case here, it will always be invalid, okay? And that underlying form is known as denying the antecedent. So let's do the truth table again for both of these. So CA, if C then A. Actually, let's do this. So these are a little bit more involved, if you notice, because we also have negations, right? So our reference columns aren't going to be enough, right? Our reference columns plus one other column isn't going to be enough, right? We're actually going to have more columns in these truth tables in order to depict all the premises and the conclusion. So we'll start again, as usual, true, true, false, false. And then true, false, true, false. And now I'll go ahead and do the negations we need. All right, let's go ahead and get our second premise up there. So not the case that A. That's, as we learned in a prior video, always just going to be the opposite truth value of A. Right, so when A is true, not the case that A is going to be false. When it's false, this is going to be true, and so on. Okay, and that was our second premise, so we want to clearly indicate that. Then we will go ahead and get our conclusion up there. It's not the case that C. So same thing, when C is true, then not the case that C is going to be false. So both of these are going to be false, these first two. And then when it's false that C, well, then it's true that it's not the case that C. Okay. So that was our conclusion. We want to clearly indicate that at the top of the truth table. Okay. And then finally, we'll go ahead and put that conditional in there, which was our first premise. Okay. If C, then A. So we'll go all the way back over to the left here. We need a true antecedent and a false consequent in order to put a false value here, right? Well, these first two are both true, but in this first row, right, the A or the consequent is still true, so that's true. But in this second row, right, the antecedent's true and the consequent is false, so here we would put a false value. Okay, and then the third and fourth rows, once again, the conditional is going to be true in each instance because the antecedent is false, right? So anytime the antecedent is false in the conditional itself is, as a whole, rendered true. Okay. So now we're in a position to step back and assess the validity of this argument. Okay, so we want to locate the premises, find out if we have any cases or scenarios, possible combinations of truth values, wherein both premises are true. The first row, they're not both true. The second row, they're not both true. The third row, they're not both true. We only have one row where both premises are true. It's the last row. And in that one row, the conclusion also turns out to be true. So we didn't find a single row where the premises were both true and the conclusion was false, which is what we need to find to determine that the argument's invalid. Since we didn't find such a row, we know that that argument is valid. Okay. Now let's go over here and do denying the antecedent. It's going to be very similar. True, true, false, false. So we need the same sort of rows, not, oops, true, false, not C. That is our second premise. Again, it's imperative that you're always as clear as possible. You keep things neat and clear. Where's my second premise? It's right here. It's this column. So not the case that C is always the opposite truth value of C itself. Okay. We need not the case that A for our conclusion. And look, you could have done the conditional first somewhere over here. What matters is that you get all this information somewhere in a column, right? It doesn't necessarily have to be in this order. I like to go sort of what's shortest first and then to what's longer, right? But in this sort of scenario, it really doesn't matter. I could have put this conditional over here, right? And I could have put the conclusion, say, all the way to the right. It doesn't matter. So not the case that A is going to be always have the opposite truth value of A itself. Okay. So that's our conclusion. Now all that we need to put up here is the conditional, which was premise 1. We're going to clearly indicate that. So we're looking for the antecedent of C to be true and the consequent of A to be false in order to label this false. That's not the case here, so it's true. Here it's the case, right? C is true and A is false, so this conditional will be false. Both of these, the conditional is going to be true because the antecedent is true in both cases. Okay, so now we step back. Let's find rows where both the premises are true. Here's a row. We'll take a closer look at this row because both premises are true there. And here's another row. So we have two rows where both premises are true. Now, is there a row where the conclusion is also false? Because that's what we need to find in order to be able to say that's an invalid argument. Okay, not the case in the fourth row. The conclusion is also true there, but look here. The third row where C is false and A is true, when we substitute those truth values, right, we'll get both premises true and the conclusion will turn out to be false. Okay, so this third row suggests that the argument is invalid. Okay, which makes sense again because, like I said, denying the antecedent is always invalid. Okay, moving on, we'll talk about a chain argument and the corresponding fallacious form of argumentation that's you sometimes see as well known as an undistributed middle. Okay. So what do I have here? Chain argument. And in these two forms, you actually have 3 basic claim variables, so it's a little more involved. Okay, so the way a chain argument works is you've got premise 1, if P then D, premise 2, if D then A, conclusion, if P then A. Okay. So again, this is a valid form of argumentation. No matter what argument you're confronted with, if the underlying form consists of this, what's known as a chain argument, then it's going to be valid. Okay, and let me give you an example. Premise 1, if it's a poodle, it's a dog. Premise 2, if it's a dog, it's an animal. Conclusion, if it's a poodle, it's an animal. Okay. Let's go ahead, before we get to undistributed middle, let's go ahead and just map out the truth table for this one, because it is a little bit more involved, and so while it's fresh in our minds, I want to go ahead and put it up here. So we have 3 different basic claim variables this time, right? So we have P, D, A, also stands for something else, interestingly. Okay. Now we have 8 rows, right? 3 different claim variables. True, 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 false, 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 false. So I want to stay neat here. I'm going to go ahead and draw lines over. Okay, the next one over, right? Half what we did on the left, so true, true, false, false, true, true, false, false. And then the one on the right is always back and forth, right? True, false, true, false, true, false. Okay, so we've got our basic reference columns over there representing the basic claims, okay, but none of our premises or columns, or sorry, none of our premises or the conclusion are just these basic claim variables. Instead, they're all conditional. So we'll need 3 different columns still, 3 new columns, okay, to the right of the reference column. So let's go ahead and just do these in order. We'll do premise 1 first. So if P, then D. This is premise 1, okay, and we're looking for a true antecedent and a false consequent in order to label this false. Otherwise, it's going to be true. Here, they're both true, so this is true. Same thing here, P and D are both true, so that's true. Here we have an instance where P is true and D is false, so the conditional is false. Same thing in this next row, okay? And then all 4, right, the final 4 rows, P is false in all 4 of them, so we know the conditional itself is going to be true, since the only way the conditional is false is if the antecedent's true and the consequent's false. So whenever the antecedent's false, the conditional itself will always be true. Okay, that's premise 1. Let's go ahead and put premise 2 up here, which is if D, then A. Okay, true. Here we have an instance where it's false because the antecedent is true and the consequent is false, so the conditional is false. These next 2, the antecedent is false in each case, so the conditional itself will be true. Okay, D is true and A is true in this one, so this is true. Here we have another instance where the conditional is false because the antecedent is true and the consequent is false. And these last 2, the conditional is going to be true in both because the antecedent is false. Okay. And then finally, our conclusion, if P then A. So we gotta skip that middle column here to look at this. So P and A, both true here, so the conditional will be true. Second row, we have an example of this being false because the antecedent is true and the consequent is false. Okay. Third row, they're both true, so the conditional will be true. Fourth row, again, the antecedent is true and the consequent is false, so the conditional will be false. And then the last four, we have an antecedent that's false, so the conditional will be true in every instance. Okay. All right, so a little bit more to it, right, with 3 claim variables, but we're already done. We've got both of our premises up there and our conclusion as well. So we're going to step back and we're going to ask ourselves, are there any rows where the premises are both true and the conclusion is false? So first, let's find the rows where the premises are both true. Here we have one. Okay, that one's false, false, false. Here we have another one. False, and here we have 2 more. So now that we've found 4 rows where the premises are both true, let's see if in any of those rows the conclusion's false. And if we can find one of those rows where the conclusion's also false when these premises are true, then we can say this argument's invalid. Otherwise, if the conclusion turns out true in every single one of these rows, then the argument itself is valid. Okay, it's true here, so that one won't indicate an invalid argument. True here, true here, true here. So every row or instance where both premises were true, the conclusion also turned out to be true. So it's not possible for this in this argument to have true premises and a false conclusion, right? So that is going to be valid. Okay. Let's do the same thing now, but with undistributed middle, okay, which has a very similar looking underlying format, but it's slightly different. It's a recurring theme here. Okay, and that slight difference is all it takes. Okay, this is always going to be an invalid form of argumentation. Okay, whenever you come across an argument that has this for its underlying form, always invalid. Okay, let me give you an example. If it's a cat, it's an animal. Premise 2, if it's a dog, it's an animal. Conclusion, if it's a cat, it's a dog. Now this intuitively just sounds crazy, right? It sounds invalid. Okay, but sometimes I'm here to tell you that sometimes the argument you'll come across arguments that have this for an underlying form, but they sound much more convincing. Okay, but this would be an analogous argument to those more convincing arguments, and they're all invalid because they share this underlying invalid argumentative form. Okay, so this reads like this: premise 1, if it's a cat, it's an animal. Premise 2, if it's a dog, it's an animal. They want you to conclude from that if it's a cat, it's a dog. I don't think so. Okay, so let's go ahead and create the truth table for this. Again, we have 3 different basic claim variables, C, D, and A. So we will need 3 different reference columns and ultimately 8 rows for this truth table. And on the far left, we always start with 4 true, oops, what am I doing? Half trues and half falses, right? So true, 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 false, 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 false. Okay, and then half that, so true, true, false, false, true, true, false, false. And then every other one, right, for that third one, true, false, true, false, true, false, true, false. And I meant to keep reiterating this as I've been doing truth tables and using 1s and 0s for true and false. I only mentioned it once in the one video. I think it's a great practice instead of T's and F's, right, to use 1s and 0s, 1 for true, 0 for false, because it's much clearer than these T's and F's, which can oftentimes look very similar. Okay? So if you missed that part, this might all seem kind of strange, right? Seeing these ones and zeros. Hopefully it now makes sense. Okay, so we have our basic reference columns. None of these reference columns indicate any of the premises or conclusions, so we know we're going to need at least 3 more columns, right? So as it turns out, we'll only need 3 more because these are pretty easy to do, right? We'll just need 3 new columns to represent each of these conditionals. So we'll go ahead and go in order again. Premise 1, if C, then A. I'm going to go a little faster this time because hopefully you're getting it down, right? When is the conditional false? Right, it's only false if the antecedent is true and the consequent is false. Okay, that's not the case here. C and A, it's true. Here it is the case. C is true and A is false, so the conditional is false. True, false, and then the last 4 are all true because C is false in every instance. Okay, premise 2 will be if D then A. So we're looking at these 2 columns. It's true. Here we have an instance where the antecedent is true and the consequent is false, so put a false for the conditional value. Antecedent is false in both of these next 2, so the conditional will be true. Both are true in this one, so the conditional, both the antecedent and the consequent are true, so the conditional will be true. Here we have another instance where the conditional is false, and the last 2, the antecedent is false, so we'll know the conditional as a whole is true. And then finally, the conclusion, if C then D. Okay, so here we're looking at these 2 columns. First one is going to be true, second one is going to be true. Third and fourth are both cases where the antecedent is true and the consequent is false, right? So in both those scenarios, this conditional is going to be false. And then the next 4, they're all going to be true because the antecedent is false in each one. So the conditional will be true in all 4 cases. Okay, so we've got our truth table representing all possible combinations of truth values for the constituent basic claims underlying this argument, right? As well as columns representing the truth values that correspond for the premises and the conclusion. Okay, so we step back and we try to find those cases where the premises are all true. Okay, so it looks like we have 1, 2, 3, 4, 5 suspects. Now we need to find out, right, if they've done it, right, meaning the conclusion is also false in those rows. Nope, it's true here, so that's fine. Aha, we found our suspect, right? Here, this row indicates that this argument is invalid because it's possible for the premises to be true and the conclusion to still be false. Okay, this row is fine, this row is fine, and this row is fine. So we found one row. Right, that's all it takes. All it takes is, one instance where the premises can be true and the conclusion is false. So when C is true and A is true and D is false, plug all those truth values in up here, the premises will be true and the conclusion will turn out to be false. So this will be labeled invalid. Okay. So hopefully going through those very common argumentative forms and also their corresponding invalid fallacious forms you found helpful. We got some practice in, working with those truth tables and using the truth tables then to decide or determine when the argument's invalid or when it's valid, right? We're looking for columns representing our premises where those columns were both true in a particular row and the conclusion was false, right? And then we would label the argument invalid. But if we couldn't find a single row in our truth table where the premises were true, right, and the conclusion was false, well, then it's valid. Okay. I want to take a minute or 2 here real quickly to talk about the short truth table method. Okay. I'm not going to say a lot about this, and I actually prefer that you use the long truth table for the most part, that method, and actually insist on it in some of the homework exercises where I think the authors left it open to you, and I said, no, you need to do the long truth table method. But I do want to kind of go through it real quick to show you kind of how it works. So let's go back to affirming the consequent. If P and Q, Q, P. So let's see, right, if we can use the short truth table method to determine whether this is valid or invalid. So what you're doing with the short truth table method is you're just keeping in mind your main prerogative, even when you're using the long truth table method, and that's to find a case of truth values for the claims involved, the basic claim variables involved, where the premises will turn out true and the conclusions false. Okay, so can we do that? Right, and in this case, we only have 2. Okay, so excuse me. What do we need to make the conclusion false in this instance? Well, there's only one thing, right? We have to make P false. Okay, and now is it possible with P being false to have both premises still be true? Well, we can make premise 2 true by making Q true, right? And so we ask ourselves, if using these truth values, right, will this first premise turn out to be true? If so, then we've found an instance, right, where these will turn out to be true and this will be false. So let's see, if we plug in a false value for the antecedent, the conditional as a whole will always be true. So we have, in fact, found a combination of truth values, right, that'll, when plugged in, will render both premises true and the conclusion false. That's why then we would say this was invalid. Okay, and that makes sense because, again, this is that fallacious form of argumentation known as affirming the consequent. Well, let's see what happens when we flip these around and do a modus ponens, right? So this is we already know it's valid, right? The valid form of it. So again, we're trying to look for a combination of truth values that would make the conclusion false and the premises still true. So we need a true premise or a true p value, the p to be the true, right? Because we want premise 2 to be true, and the only way to make that true is to have p be true. Okay, now when we plug these in, does that make the first premise true? No. In fact, a true antecedent and a false consequent will render the whole conditional false. So it's not possible, right, to plug in truth values here where the conclusion will be false and yet both premises will be true. So since we couldn't find such a case, right, we would know this is valid. Okay, let me do maybe one more and we'll call it quits here. Let's go back to this. Okay, so now we're doing 3 basic claim variables. Okay, what do we need to plug in for the truth values of these basic claim variables to yield a false conclusion? Well, there's only one thing we can do, right? The antecedent will have to be true and the consequent will have to be false, right? Because that's the only way to make a conditional false. There's only one way to do it, okay? This has to be true and this has to be false. So let's see then if we can still, right, so we've turned this into a false conclusion, right? Let's see, using those truth values, if it's possible to make both premises true, okay? Well, here, with a p of a t, or is a true truth value for p, right? Then this, if we want to make this true, q is going to have to also be true, right? Otherwise, if q is false, then the whole conditional will be false. And we're trying to make both premises true to show that it's possible to have all the premises true and the conclusion false. Okay, well, we can still do that, right? We just need to make sure q is true. So let's see. So we've made that true. All right, let's make sure that premise 2 can still be true using all these truth values we've already had to determine. Okay, so r is false. Okay, well, that's good because we know that with the false antecedent, the conditional itself is going to be true. Right? So lo and behold, we found a combination of truth values for the basic claim variables wherein it's going to be the case that the premises are both true and the conclusion is false. So we would know then that this argumentative form, right, and this whatever argument is being represented by this logical notation is invalid. And that makes sense because this is, again, the undistributed middle, that common fallacious form of argumentation. Okay, so what we've done is we've gone through and talked about assessing arguments using the truth table method. Right, I've gone through and discussed the most common forms of argumentation, both the valid forms and also some invalid forms. And we've given examples for all of them and discussed their truth tables and tried to show you, right, how you work through the truth table and then to see why they're in fact valid or why they're in fact invalid. And then we spent a few minutes here discussing the short truth table method as well. So hopefully you found this video helpful as usual, and good luck with everything as we progress through the semester.